In the last course module, we had a very thorough look at all the important basics of Flutter and Dart. Now, when you're building Flutter applications, things will occasionally go wrong. You'll have errors. And in addition, thus far, we only tested our app on an Android emulator, but in reality, you of course want to test your application also on iOS simulators and on real devices. Therefore, in this module, we'll have a look at how you can run your app on different platforms, so on Android and iOS, and on real devices, and how you can test your app there. We'll also have a look at error messages, because things will occasionally go wrong. You will have some errors in your code, and reading and understanding error messages and fixing errors is a crucial part of development, so we'll have a look at that. And then there sometimes also are errors without error messages, because they might be logical errors in your code, which are hard to spot and fix. For this, we'll have a look at the Visual Studio Code debugger, which you can use and how to use it to walk through your code in detail and have a look into your code whilst it is running to really understand where a problem might be stemming from. Now that all helps us with fixing issues in our code, but sometimes the UI doesn't look the way it should look, or we're not sure whether we're updating some part of the UI unnecessarily. And for that, you will learn how to use the Dart dev tools and the Flutter inspector, which are tools that allow you to visually debug your app, so understand the user interface and why it looks the way it does look, and also get a brief insight into how to debug or measure performance and get a feeling for that. This is it for this module. Let's dive right in. Thus far, we only tested our application on an Android emulator. And that is generally fine, of course. Android is one of the major platforms you typically develop for. But of course, you might also want to test your app on an iOS simulator if you are developing on a macOS system, because you can only build iOS apps on macOS systems, unfortunately. Or maybe you don't want to test your application on an emulator only, but also on a real device. And we'll have a look at all these other use cases or these other ways of running our application over the next minutes. So here's the Android emulator, and I created it with the help of the AVD manager, as I showed earlier in the course. Started through Android Studio, you can open that AVD manager and spin up your emulator there. So that is what we already did. How could we now launch this app on a real Android device though? For that, you first of all need to prepare your Android device. And that means that you need to open your settings on your device and there choose these developer options. However, you might not have that option in your menu. In this case, go to About Phone and there tap on that build number 7 times. Now that might look strange, but this actually gives you this developer options menu item here. So tap on that build number here 7 times. I already activated it, so that's why I get this message. And once you did this, you should have the developer options here. Now there, generally make sure that it's turned on. And then there's one specific option you need to enable, and that is USB debugging. Make sure that USB debugging is switched on. Thereafter, connect your device, your Android device, with a USB cable to the machine you're working on, so you're developing this Flutter app on, and now you should be able to boot that Flutter app onto that device. Now here actually, in this Flutter app which I have here, I now can choose my device in the bottom right corner, here in Visual Studio Code. I now have the choice whether I want to use the emulator or my device here. And in Android Studio, you would also have an option of choosing where to boot it. If you're not sure how you can choose that, you can always simply quit the emulator so that you only have the connected device as the only device on which the app could be installed and run, and then the Flutter run command or running it with the debug command here should automatically pick the connected device. So here I selected the connected device in the drop-down menu, and with that, I can run the app as I always run it. So either with the Flutter run command or in Visual Studio Code here with debug, start without debugging or in debugging mode, but I will go without debugging since this is a bit faster. And now the app will be built as it was before, and it will then be shipped onto the real device and will be installed and launched there so that you can test it there. Now let's wait for that to finish. So here's the app running on my real device, on my real connected Android device, and of course there I can interact with it just as I could in the emulator, which is good. You should see the same result here. Now when developing an app, testing it on real devices is really crucial and something you absolutely have to do, because whilst the emulators are really good and really, well, emulate real devices, it's just a simulation. Nothing can replace a real device. So testing on a real device, and if possible on different real devices, is something you should do as part of every app development process. So that was Android, emulator, and the real device. Now what about iOS? Now important, to build an iOS app you need the macOS operating system. That is a restriction applied by Apple. You can't build your Flutter app for iOS on Windows or Linux. You need macOS. If you are on macOS, then you can of course also test the app on a simulator or also on a real device. Now for that, you need Xcode, and I showed you how to install Xcode in the first module of this course, so you should be able to launch Xcode and see that welcome screen there. Now in there, open another project, click that button, and then navigate to your Flutter project folder, and there to the iOS folder and choose that runner Xcode project file. Open that as a project in Xcode. Now here you could write code, but that's not what we'll do. We'll stick to Visual Studio Code for that. But here we can also configure this so that we can run it on a simulator. And there's one important thing you need to set up. Click on this project icon here, or on this root icon here, this root element in the left bar here, where you can get by clicking this folder icon here. So click on that so that you have this view. And then here you might see that signing for runner requires a development team. For that here in this drop-down, you should choose a team, and normally you should have one. If you don't have a team here, click on Add an Account and add your Apple account with your Apple ID here to Xcode. So here you can either create a new one if you don't have one, or you log in with an existing account. Now, important, for developing iOS apps, you need an Apple developer account, and you can activate one for your Apple ID, which you probably already have, by going to developer.apple.com and there click on Account. Now here you now have to log in with your Apple ID, and a process should start which turns you into an Apple developer. Whilst you need to agree to some terms, what you don't need to do to develop apps is pay. You will have to pay a fee to really publish your app to the Apple App Store, but for developing and testing your app, you don't need a paid account. So no need to pay, you just need a normal Apple developer account. Once you have that, you should be able to select your team here in Xcode and use that for this project. Now once you did this once, you should be fine. And now you can run your project either through Xcode by selecting a simulator here and clicking the Run button, or select a real connected device if you have one. But you can also do it here from within Visual Studio Code by going to the terminal, and there in your normal system terminal you can run open -a simulator.app. And what this will do is it will bring up an iOS simulator. Here it is. Let me close Xcode, we don't need that anymore. Let me move the Android simulator over there. And now here is the iOS simulator. And again, you could have launched that through Xcode as well if you wanted to. Now this is booting up, and as soon as this simulator is done booting up, we can select it down here. Oh, well, actually I can already do that. So you can select your simulator here in the bottom right corner of Visual Studio Code by clicking on that bar here, then select the iOS device, or as before, shut down all other simulators, disconnect all other devices from your machine, and it should automatically pick this one. And once you did all of that, just as before, you can again run your app there with the Flutter run command or through the debug menu here in Visual Studio Code and start without debugging, for example. And now this will also build the app, but it will now build it with the help of Xcode, because now an iOS app is built, and once it's done building the app, it will ship it onto the simulator. So let's wait for that to finish. Here's the app running on iOS now, and one thing you might notice is that it looks exactly the same as it looks on an Android device. The reason for that is that Flutter does not automatically adjust the styles to the iOS look. It does not automatically give you that iOS look. Remember that with Flutter, you in the end use a framework that controls every pixel. It's not using native device or native platform user interface elements. So a button here is not compiled to an iOS button for iOS and to an Android button for Android. Instead, a button always looks the same because Flutter draws it onto the screen. It's not using some platform primitive, not a built-in UI element. And therefore, these apps look similar. Now, later in the course, you will indeed learn how to adjust your look though. Other than the font family is actually different automatically. But you will learn how you can adjust your app to look like an Android app on Android and an iOS app on iOS, if you want that. Or you create your own look for all platforms. Whatever you need. All that is possible with Flutter, and we'll of course have a look at all these options throughout the course. Now, more important than the look is, of course, that it works correctly. And that is the case here. So now we can also test the app here on the iOS simulator, and we're just fine. Everything is working correctly. Now, what about a real iOS device then? So this here is now a live recording of my connected iPhone. So now I want to launch the app on that iPhone. And once you connected your iPhone or your iPad to your macOS device, on that device, you should be prompted whether you want to trust the connected device, and you should of course choose yes there. And you should then be able to select your device here in Visual Studio Code in the bottom right corner by clicking on that bar as well. Now, I'm actually not able to choose it here. And if that's the case for you as well, you can also use Xcode, open that project again, which I showed you earlier. And then here in the drop-down, select your device. And you can simply now launch the app on the real device here by clicking that play button. That also works, and it will also build your app here and ship it onto that device. So let's wait for this build process to finish then. And here's the app launching up on my iPhone now. By the way, don't worry if that first launch takes a while. That only happens here because we're still having a development mode app, which is not optimized at all, which has a lot of overhead inside of it to speed up development. Now, this is the running app though, and just as on the Android device or on the simulator, of course, I can interact with it. Now, the look is the same as on the iOS simulator, of course, not adjusted to iOS for the reasons I explained. But the important thing is that we now also can test our application on the iOS device. And just as with real Android devices, of course, if you plan on shipping your app to the Apple App Store, you should also test the app on as many real iOS devices as possible. So you learned how to launch the app on different simulators and devices. For the majority of the course, I will work with the emulators, and they're mostly with the Android emulator, simply because Android is the system everyone is able to follow along. iOS apps can only be developed on macOS systems, and not every student has a macOS system available. So Android will be the focus of this course, or the Android simulator will be the focus, I should say. We will nonetheless build apps for both platforms. And since we'll work a lot with simulators, you should know how to use them. For the Android simulator, you have this control panel here on the right where you, for example, can rotate the device. Now, important to also apply the rotation effect here, you need to open your settings here or scroll down, bring up that status bar on the emulator and make sure that device rotation is turned on. With that, by pressing these buttons, you can simulate that the device is rotated and then also confirm that your user interface looks good in landscape mode. Of course, in this course, I'll also extensively cover how you can render different user interfaces, different layouts for different device sizes and device orientations. So that is one important thing you can do here. There are other things which will become more useful once we later also work with maps and so on. Here, if you click on these three dots, you have even more options of configuring and fine-tuning this. On the iOS simulator, you can also rotate the device. You have all your options up here in the toolbar or in this top control bar here. There under hardware, you can also rotate the device, or you use one of these shortcuts here. And there, for example, you can also control the soft keyboard and enable that, disable that, so that you can either use your real keyboard on your MacBook, on your macOS device, once we have some text inputs here, or that you use the soft keyboard on the screen. Simply play around with these settings to get a feeling for what you can do there and how you can control these emulators for testing the app in the way you want to test it. Now that we know how to launch the app on different devices, let's dive deeper into which tools we have to effectively debug it. And with debug it, I mean things like solving errors, finding logical errors in our code, and also things like checking what is responsible for rendering the user interface in the way we see it, as well as some performance monitoring. We can do all of that very conveniently with the help of Flutter and some special tools Flutter gives us. So in our code here, what could go wrong? There are different kinds of errors you can get when building a Flutter app. One of the most common errors, and thankfully also a kind of error that is relatively easy to fix, is the syntax error. For example, you might forget a semicolon from time to time. In such a scenario, when you start your app with or without debugging, doesn't matter, you should automatically get a complaint here, and you can have a look at the errors you're getting, which you should also get here in your IDE, and also here in Visual Studio Code in the Problems tab if you go there. So there it should already hint you at some of the obvious errors you might have in your code. So that's relatively easy to fix. In addition to that, you might also have errors which aren't recognized by your IDE, but which pop up when your app runs. For example, we might have an error where we add 3 to our current question index, and the result will be that we exceed the range of available indexes right after answering the first question. Because we increment the index from 0 to 3, we only have 3 elements in the list. As you learned, the list indexes start at 0, so the index 3 would target the 4th list element, which we don't have, and therefore this will cause an error. However, the IDE doesn't pick up that error because it doesn't analyze the data we're working with and so on. We will get an error though once we run our application. So here let me launch the application and then show you which kind of error we get and how you can resolve such errors on your own when you get them. With the app running here, once I click a button, we get to the result screen because we don't even try to access an element with that index. That changes, however, if I try to add some code here. So here, if I take my questions and I want to print the question item for the chosen question index, then this again will be code which is accepted by my IDE, which is not detected as a problematic code, and which therefore will now, however, cause an issue once our app runs, because now I'm doing something invalid here when our application is running, so we will get a runtime error. So let me restart the quiz here. And now, whilst we don't get an error message here, sometimes you also get error messages projected right into your app user interface. Whilst that is not the case here, we do get an error here in the debug console. And that's good, because whilst this always looks scary when you see it the first time, it actually holds useful information that allows you to fix that error. Now, the important thing you have to know here is that for Flutter errors, the most helpful messages or the most helpful things are always located at the top, at the beginning of the error message. So let's scroll up all the way to the beginning of the error message. And then here we see that a range error was thrown. Okay. And that we have some invalid value, which is not in the range 0 to 2, the value seems to be free, something like this. Maybe at this point of time you already have an idea what could be wrong. And with time you get more and more experience and you see more and more errors, and then it's pretty clear that a range error always means that you tried to access some element in a list or in a map or anything like that which doesn't exist there. But in case you're not entirely sure what happened, or you know what happened but you have multiple lists in your application and you want to find out which concrete code snippet caused the error, you can look a bit further down, and then you see that it was located in the myAppState class and there in the answer question method, and it even gives you the concrete line number 68. And then you can go to your code. You can even click on that line here, by the way. You can click on that line and you see, okay, this is the line that caused the error, and now you can analyze what's the problem. And here, of course, the problem is not the line itself, but the line before that, where I set the index to an invalid value. Now, this is how you should work with such error messages and how you should read them. Don't run away when you're getting an error. Read the error message. The most important part is located at the top typically. Analyze the file and the line at which it is pointing you and find out what could be wrong there and take this as a starting point for searching the error. Now, sometimes you have a really hard time finding an error, especially if it's not an error that throws an error message, but if it's some logical error. Now, what would be an example for a logical error? An example would be that we indeed add 2 here because maybe we mistyped and will now never get an error message because I commented out that line. And in our widget tree, we also won't run into a situation where we select the wrong question because we render the result screen once we're out of questions or once our index exceeds the question's length. So we'll never get an error message here. And still, we have the wrong behavior. When we test our app on the device, we seem to skip a question, and we only got 2 questions until we reach the result screen. So something is wrong. But here we got no error message. So how can you now narrow down the issue and find out what's wrong? There are 2 ways of doing that. The quick and dirty way is that you use print. Here, for example, you could print question index to find out if something's wrong with that index. So we could do that here. And if I save that and I now click through my question or through my answers again, then we see that the question index is 2 and 4. And that might already be all we need to know to find out, oh, something's wrong with the index. Why is it increasing by 2? It should be increasing by 1. So this might be one way. Using print in your code is a nice way of printing out the current state of a given value and find out if it has the value you would have expected. But if you have more complex problems, using this print debugging can be too cumbersome. And therefore, you should use the more powerful built-in debugger. For that, quit the running app and now run the app in debugging mode. So start debugging, not start without debugging, but start debugging or use the respective shortcut. Now this will also launch the app, but as you can already tell, in a different mode. Here in Visual Studio Code, it automatically enters the debugging view, which you can also activate manually here under View, Debug. You can always go back to the Explorer if you want to see your files. But in View Debug, you now can do more than just add a couple of print statements. For example, what you can do now is set breakpoints. You do that by moving your mouse cursor to the left side of the line numbers here in your editor view, and then you can add a breakpoint by simply clicking there. Now, a breakpoint will halt the code execution whenever it reaches this code line. And you can then even look into the values of variables and properties and find out if everything has the value you expected and so on. You can also, if you want to, place breakpoints here in your widget tree. Simply try a couple of different spots and see where code execution stops. So now let's wait for this installation to finish, for the build process to finish, and let's see how the breakpoints work. Here the app already stopped. It launched the app and it stopped right away because I placed a breakpoint in my main.js file in my myAppState class in the main build method, therefore, right here when the widget tree gets built. And now you can use the controls here in the top right on this bar to move through your code. With this icon here, you move to the next line of code, so to the next instruction to be precise. With the arrow next to it, you can step into, for example, a function call so that you don't skip it and just proceed with the result, but that you really can go through each step in the function. And if you are in such a function, for example, you can use this arrow here to step out of it. So here I'm in the build method of the quiz widget now, because I stepped to the next step. We see that now here build was called. And the cool thing is we can now step into this. And if you hover over things like the context here or over questions, you can see what's in there. You can inspect this, you can find out what values are in there, and if that all has the values you did expect. For example, we can find the current question index value. You can also add values to the watch list here on the left so that you can watch how they change as you progress through code. So here, for example, I could add question index, and now you see it currently has a value of 0, and we can check whether it stays that way. Now, once you're done for the moment, you can always press the play button here on the left to continue code execution until the next breakpoint is hit. And you see right now question index is not available because we're not in that code snippet anymore. Now, however, if I press a button, I'm taken back to the editor because I also had a breakpoint in answer question. I placed that earlier. And here we can now see what the total score is, for example. We can see what the question index is, and here we might then already spot our mistake, for example, our logical mistake. Again, we can step through our code step by step if we want to, so that we progress, well, step by step. We always can see which variables we currently have in the method we're at the moment. So score, for example, or this, which refers to the overall class, where we can therefore inspect all our properties of that class, bunch of internal properties managed by Flutter, but then also, for example, our underscore questions or our question index property. And with these tools, you should have everything to deeply analyze your code, what's going on there, what's changing, why it's changing, and hopefully spot logical mistakes. Now, if you're done, you can always press the play button, and if you want to get rid of breakpoints, you simply click on them to clear them, and now your code won't stop there anymore. So that's the debugger. By default, I would recommend that you run your app without debugging though, because the debugger injects some extra logic into the running app and simply makes the app a bit slower. And therefore, you have a faster development cycle. You can work on your app faster, see updates faster if you start your app without debugging. But dive into debugging mode whenever you have a complex problem where you want to find out what's going wrong. Now, that all were tools, however, that helped us with finding and fixing errors in our code. But what if we want to have a look at our user interface and find out why elements are positioned the way they are positioned, or find out how performance of the application is? For that, we have yet another tool we can use. And for that, in Visual Studio Code, you can hit Command-Shift-P or Control-Shift-P on Windows to bring up that command panel. And there, if you type Dart DevTools, it should give you that option of opening the DevTools. Hit enter there. Maybe you also were prompted for it before in the bottom right corner. That's also possible. Once you hit enter there, a new tab should open up in your browser here in Chrome. And that now is a web page that is connected to your running emulator and gives you some live insights. For example, here on the left, you see the current widget tree that you see graphically here in the emulator. Here is its data representation, so to say. And you can click on widgets there to learn more about them. Here, for example, you see the text that's inside this text widget, which is clearly the question text here at the top. And you can learn more about its settings, like the color, if it has a specific style, and so on. And you can do that for all. You can do that for all these containers and so on to learn how they are configured. Now, at the moment, at least, you can't change the configuration here, but at least you get a feeling for how your widget tree looks like and how it is configured. You can also go into select widget mode here, activate this by tapping on it once, and thereafter you can select widgets here in the emulator. You can simply click on them, like on this button, and now it's selected. You see some helper lines that show you how much space this widget takes up and how it is rendered. And on the right side, or in your browser there, in the DevTools, it is also automatically selected then, and you can learn more about it and how it is configured. You even see, for example, here for the button, how it is built internally by Flutter, that it uses a couple of other Flutter widgets to build that button. For example, a container, a center widget, and so on. So here you can really have a deep dive into your user interface and see why it is built in the way, well, it is built. In case you're not interested in selecting widgets, here in this Flutter DevTools or in the Start DevTools browser window, you can also click on Debug Paint here. What this does is it adds some helper lines here in your UI that basically helps you understand why your app is laid out or structured in the way it is laid out or structured. You see that, for example, this text here is centered. You see some helper lines around the That Button widget, which indicate that there seems to be some extra margin, and so on. So that can be really helpful for getting a feeling for why your app looks the way it looks like. You can also paint the baselines here, which gives you some helper lines for the text baselines. Can be useful for aligning things that are sitting next to each other. So these are nice visual helpers here. You also have a performance overlay, which you can activate, which helps you understand how performance of your application is. Though be aware that performance in development mode on an emulator is never great and never as good as on a real device once your app is built for production. So using it here in development mode is not really something I would recommend because you get a wrong idea of how performant or unperformant your application is. But once you build your app for production and you're testing this app, you can get a feeling for it if you have any places in your app that you might need to tweak to improve performance. It's not something we'll care about at the moment though. What you also have here in the DevTools is an option to turn off that debug banner in the top right corner in case that was annoying to you. And really useful, the repaint rainbow. And that's something I want to have a closer look. So what's the repaint rainbow here? I activated it, and the result is that now, if I do something in the app, like tap a button, I get some borders here. And these borders indicate what was repainted. And the more often something gets repainted, the more often the color around that widget changes. And therefore, this is a great tool for finding out whether something changed on the screen that shouldn't really change. For example, here when I click the buttons, it makes sense that all this part here changes. However, in our application here, since we manage the entire state in the main Dart file in the myAppState class, which is connected to our root, to our topmost widget, the myApp widget, since we manage our core state in here, we always rebuild the entire app and the entire page with every button click. That's the reason why we also see boundaries or borders, green borders, around our app bar, for example, because that's also rebuilt when our chosen question changes. Now that's normal for this application here, and it's okay for this simple app, but a possible improvement here could be to wrap our core quizzing logic with the quiz and the result into a separate widget, which then manages the state, so that the scaffold and material app and app bar widget are in a separate widget where the state is not managed, so that the build method for this widget, which contains these never changing elements, is never triggered, and we have the things that do change in a separate widget. That would be one possible optimization which won't matter here, but which we will apply later in the more complex apps we're building to ensure that we really only trigger the build method on the widgets that did change and not trigger it on unrelated widgets which don't really need to update. because in this app, the app bar never changes. There is no need to trigger build for it and therefore repaint it on the screen. One important side note at this point though, repainting on the screen is not the same as recreating it. It's of course great if you can avoid it being repainted, for example by outsourcing the parts that do change into separate widgets. But even if something is repainted, Flutter might be able to simply take the previous element it painted, so the previous app bar with the exact same color and text, and reapply that. Then it's still worse than not repainting it, but it's better than recreating it, which would mean that it also had to internally rebuild the app bar, which takes up a bit more performance than just drawing an element which it already knows, which it already has stored in memory, back onto the screen. It's a small difference, but it does matter. An element might be repainted, but Flutter might be able to take an existing element from memory. That's better than if Flutter has to create a new element and then paint that element. Of course, the best is if Flutter neither has to recreate nor repaint an element. But we'll take a closer look at such optimizations later, once we're a bit more advanced and we know a bit more about Flutter. In the Dart DevTools, we also have more options here at the top. We're currently in the Flutter inspector with all these tools. Now there you also have a timeline. This can be useful for recording your app. If I now tap here, you see some bars appear here. This can also be great for basically debugging performance, but you should do that in production mode, not in debug mode. We even get a warning here that this is not really a good indicator for how our app would perform once we ship it to an app store. But once we do have it in production mode, we can test it here with the timeline and basically get another tool for understanding the performance of our app. We can also spot its memory consumption, which can be useful for detecting memory leaks. If that keeps on growing over time and it never frees up memory, then you might have some spots in your code where you maybe store data that you never use thereafter, but you also never let go of. Also something we'll have a look at later in the course. And then here, last but not least, logging shows you some log messages. Well, typically that's not too useful, but from time to time you might find some useful information in here that you're interested in. The most important tool, however, is your debug console here, and for visual debugging, the Flutter inspector with the tools I walked you through in this module.